Hello everybody, and welcome to my .NET Parallelism presentation. Here's my machine spec. It's running an Intel Coffee Lake chip with 6 physical cores and 12 virtual cores. Now let's talk about thread. First, we will talk about definition of a thread. Thread is an execution path that can run at the same time with other threads due to its independency. Since each thread can be defined with a unique flow control, heavy computational problems can take advantage of threading by dividing small chunks of computation into different threads. The cost of creating a thread usually around 1 megabyte of memory. Now let's talk about thread in .NET framework. To create a thread, we can use the following syntax. Here, I create an instance of a class thread object and then pass into a delegate action function, which is run. The declaration will put a thread state into a ready state, waiting to be executed. To start a thread, simply call the thread method start. As you can see, I called the thread instance start method, and now the thread is alive. We can check it by accessing the isAlive property. So printing out this statement will return true. When the thread is finished, the delegate passes into its constructor, the thread will exit, and the lifecycle ends here. There are two main types of thread, foreground thread and background thread. The main difference between these two is foreground thread will keep the process alive even though the main thread is finished its execution, while the background thread will be exit as soon as the main thread is done. This is a simple program using a thread library. Here, the delegate action function must be a void function and take in a object thread ID. So the output is quite simple. It's simply replicate the thread lifecycle. So you can see the main thread has n, and the process will not execute until the child thread is finished. So let's change the type of thread from foreground to the background. Simply by changing its property, its background to true. Now look at the output. You can see that the main thread finished its execution and exit, and the child thread exit along with it. So it never had a chance to finish its execution. To ensure the child thread has enough time to finish its task, we can use the method join to prevent the main thread from exit until the thread is finished. So by simply calling the join method of the thread instant, the main thread will wait until the child thread is finished. Now we will move on to matrix multiplication with threading. Here I create an array of threads, and for each thread I pass into a partial matrix multiplied delegate function, and then I start the thread. Here I loop through all of the threads in the array and call the join method to ensure that it's had all the time to execute its function. Sorry for that. The partial matrix multiply is quite simple, where the start index is based on the thread ID, so each thread will execute the same amount of work divided evenly on each thread. Here, the end index we must choose. For most of the thread, it will be the start index plus the number of works divided equally on each thread. But at the final thread, if we choose to go with the start index and the number of works, it will just execute the number of works that we should execute. So this ternary operation will just make sure that we will not execute exceed the amount of function we need. So we just return n when the number of the start index and the number of work, the sum of two of those are bigger than the total amount of work. So the best result was achieved by using all of the available cores. So here, according to the chart, you can see I get 6 times speed up by using all 12 cores. Let's move to the thread pool. Thread pool is a stack of threads that can be used to perform a task in the background. The thread pool can come to handy when you want to optimize the usage of a thread by providing the ability to reuse a thread that has finished its previous task. And you don't have to manage the thread like creating a thread instance, because this was handled by the CRL. The recycling feature helps to avoid overheads caused by creating and destroying a thread whenever a new task comes up. So here is a matrix multiplication with thread pool. I'll create an array of events to signaling each thread and wait for all the threads to finish its task and then exit. So the result I get was quite similar to creating an array of threads. It's about 6 times speed up. And here you can see it used all 100 CPU at some certain point of time. So we will talk about thread safety. Threads share data when they are referring to the same object instant. When working with multi-threading, it's important to be aware that threads can access the same address of memory at once and modify it or read it, which can cause unwanted results. So here I create a simple function which will just print out the purpose is printing out this once. So finish is a static field, Boolean field. So if I run the thread and also run the run delegate action on the main thread, it will result in printing out twice. That's because these two threads share the same resource. So here is a simple diagram explaining what happened. So both of the threads will go to the resource and read the static boolean. And when the main thread is reading the state, the second thread will see the state as unchanged because it hasn't finished modifying the state. So that's why the finished state change print twice. The expect output is to print it once. We can prevent the above behavior by using lock feature. Static bool finish false. So we can declare an object locker, and locker can use to allow only single thread to access critical code section at a time, while other thread that want to access this section had to block or wait until a thread is released by the current thread. So here, just a simple code to demonstrate it. So if we put the crucial code inside a lock, each thread will come to here and lock the object until it finishes. It will release the object, and the other thread that try to access the code will be blocked or wait until the locker is released. So as you can see, the result here is only the console only print 1 because we have the lock. And if we declare the boolean as a local variable, each of the thread will create its own local variables, so the finished state change will be printed twice. Thread deadlock happens when two threads holding each other desirable resource lock and waiting each other to release that lock. So here, the first run will lock the locker A and then sleep for a second, as well as the locker B. The second method will run the locker B and sleep for a second. So both of these happen at the same time, so when they are awake, they will try to access locker B, which is possessed by the run B2, and the same happens to the run. So this thread will just sit there and wait. Moving on to the test parallel library. Introduced in the .NET Framework 4, TPL can be considered as an upgrade version of system threading namespace since it provides higher level abstraction when dealing with threads. The advantage of TPL is lightweight, optimized to reduce overheads, creating a new threads. Parallel 4 is equivalent to the normal for loop, but rather than execute each loop sequentially, it executes the loops in parallel. So as you can hear, I replaced the traditional for loop with a parallel for method, and it will start inclusive from 0 and exclusive to n. And the result is quite similar to the other thread pool and an array of thread, 6 times speed up. So as you can see, 12 cores is utilized during the process. So in summary, the thread will give the programmer a low-level access of the work with the operating system by allowing self-creating and managing threads. The creation and managing, so this is, so the cons of thread is the creation and management of threads needs to be carefully taken by the programmer. to get the most optimized usage of memory and avoid overheads. While using thread pool will reduce the workload of creating and managing threads for the programmer, and optimize the thread usage by recycling used thread, which help reduce overhead can cause by creating too much thread. And the disadvantage of thread pool is much less control over thread creation, as the CLR will take care of this for the programmer. And for the task parallel library is a perfect combination between thread and thread pool, can be considered as a high-level abstraction for thread, mainly used for achieving concurrency but also reduce the complex of doing tasks in parallel. Here is the comparison between .NET Threading and the other language. As you can see, all of this will get constant speed up as the number of threads increase. So the Java thread is the way Java deal with thread is quite similar to .NET Thread. Instead of passing a delegate function, it passes in a runnable object. To me, I think the .NET Thread is the most easy to use, and it gives you pretty good control over the thread. Thread and thread pool usage. Create concurrency for application, bring better user experience to the consumer. Gain speed up for heavy computational program by dividing the workload into small chunks and run them in parallel. Improve the server responsiveness by handling multiple heavy client requests on different threads. Optimize resource in terms of multi-threading on process. So like you don't have to create another thread, another process, as they are often very expensive. You just create a thread and run in parallel in the process. That's the end of my presentation. Thank you for listening.